Hello everyone, myself Dr. Nilappa, Associate Professor and HOD of ECE Department, Government Engineering College, Kushal. We will continue with the Module 4, which is about Laplace transform. And as you all know that this video is part of Learning Management System under the Department of Collegiate and Technical Education. In the last previous sessions, we have discussed all the properties of Laplace transform. Starting from linearity to we have closed or ended with initial value theorem and final value theorem. Now in this session, we'll try to take up some examples using properties or based on the properties of the Laplace transform. And usually these examples, like maybe finding or determining some equation, Laplace of some equations or some functions, or Laplace transform of some pulses, some functions which are expressed in terms of the waveforms. Let us take up the first example. Let us start with the example, that is, find the convolution of two identical rectangular pulses. Each rectangular pulse has unit amplitude and duration equal to 2t seconds. Also, the pulses is centered at t is equal to t. According to this example, if I draw a pulse or function which is shown in the figure A. You can see here that the duration of this function is 2t and which is centered at small t is equal to capital T. The amplitude of this function is equal to 1. The amplitude of this function is equal to 1. And what is the question is here? Find convolution of this function. This function means when this function x of t is convolved with the same function x of t. What is the convolution? Let us say y of t. What is y of t? When x of t is convolved with x of t only with the same function. Right? That is what will have to be determined. Using the properties of the Laplace transform, that is very, very important. Therefore, in order to solve this example, how this x of t is constructed, will have to be discussed first. Here, what is this function x of t? You can see up to 0 to 2t, its magnitude is equal to 1. After 2t, its magnitude is equal to 0. Therefore, this function will be constructed by the step function. Step function. That is, let us say, let me write a small step function here. This is your step function. Isn't it? Right? Now, let us assume that this is 2t. Here 2t. And let me define one more step function which will be starts from at 2t. Means that this is u of t, and this is also u of t, but it is delayed by 2t. It is delayed by 2t. Therefore, when I do this minus this, then we'll get this function. Then we'll get this function x of t. That is what it is done here. You can see here u of t minus U of t is nothing but step function which is having magnitude is equal to 1 minus u of t minus 2t. U of t minus 2t is nothing but step function delayed by 2t. Therefore, if I take Laplace transform for this, as you all know that, as I said many times, that we'll use the LT pair to determine the Laplace transform and even to determine the inverse Laplace transform. Now, LT of step function is, unit step function is 1 by s. LT of delayed unit step function is 1 by s e to the power of minus 2ts. Therefore, 1 by s you can take it outside, 1 by s inside the bracket 1 minus e to the power of minus 2ts. This is our x of s, LT of this function x of t, which is shown in figure number A. Figure A, that is figure A. But the question is, need to find out convolution of x of t with x of t only. That is y of t is equal to x of t is convolved with x of t only. Therefore, what is going to happen if I take LT for this function or this equation y of s? It is going to become y of s, because y of s is LT of y of t is equal to your LT of x of t is nothing but x of s, and remember here convolution operation in time domain becomes multiplication operation in the frequency domain, and LT of x of t is also x of s. Therefore, x of s is multiplied with x of s, that is going to become x square x of s, x square of s. Write it. I think you got my point here, how I got y of s as x square of s here. Next, what I'm going to do, substitute for x of s, which we have already got. Therefore, what is that? 1 minus e to the power of minus 2ts by s whole square. Expand this now, right? Therefore, if you do that, your y of s is equal to 1 by s square minus 2 by s square e to the power of minus 2s plus 1 by s square e to the power of minus 4t. It is like a minus b whole square formula. Therefore, what is important is, now I need to find out the convolution of x of t is convolved with x of t only. Therefore, for this I must take inverse LT. When I take inverse LT, again I must use the LT pairs. Therefore, now when I take LT for inverse LT for y of s, it is going to become y of t. Then here 1 by s square, that is ramp function, and 2 by s square, it is delayed ramp function multiplied with the step function, and 1 by s square, what is this? It is ramp function, delayed ramp function. Therefore, now you have got this. If I draw this, I am getting figure number B, which is shown here. That is r of t minus delayed ramp function, its magnitude is 2. Here t minus 2t plus r of t minus 4. If I do this operation, addition operation, then I am getting this function. Therefore, y of t is convolved with y of t is equal to, which is nothing but x of t is convolved with x of t only, which is nothing but y of t, that is which is shown here. Therefore, in terms of equation, y of t is equal to r of t minus 2 or t minus 2t plus r of t minus 4. This is how you have to look at the example, what is mentioned and what exactly want. Accordingly, go and take LT or take invert LT, inverse LT, depending upon your convenience to solve the particular example. You have to go through some more examples. Let us will go through some more examples. Try to make you to understand in the better manner. Next example is here. Find the Laplace transform of a periodic signal x of t, which is shown in figure A. Here is, which is a periodic signal which repeats after 2 period of t. Period of this periodic signal will be 2. It is 0 to 2, again 2 to 4, same thing is repeating, 4 to 6, again it will be repeating. Therefore, the period of this periodic function is t is equal to 2 seconds. Right? Now, this function x of t will be treated or represented as shown in the next figure. We can see here that x1 of t, here 0 to 2, its magnitude here 1, which is mentioned here, right? xa of t is this, and g of t, which is there. The earlier what figure we have represented is separately, which can be separately represented and later combined, has this x1 of t, which is shown in the previous slide, is equivalent to multiply this function with this function. Therefore, x1 of t is equal to this function into this function, right? Accordingly, this figure, this xa of t minus t plus 1, right? You can see this. Accordingly, write it, multiplied by u of t minus 1. Therefore, same thing written in terms of the equation, x1 of t is equal to minus t u of t plus t into u of t minus 1 plus u of t minus 1. If I do this mathematical operations, then finally I will get x1 of t is equal to u of t minus r of t plus r of t minus 1. As you all know that this is the step function, this is ramp function, this is delayed ramp function. If I do this operation, I am getting my what? The function x1 of t, which is defined in the example, Therefore, if I take inverse LT for this x1 of t, I am getting x1 of s, which is as follows here. That is here u of t 1 by s minus here r of t, which is 1 by s square, that is LT of the ramp function is 1 by s square, delayed ramp function 1 by s square e to the power of minus s. Combine this by taking LCM in the denominator and rewrite as x of s is equal to, that is x1 of s divided by e to the power of minus st, which you can further simplify and getting as s minus 1 plus e to the power of minus s divided by s square into 1 minus e to the power of minus 2s. Next example, which is given here. Determine the Laplace transform of f of t, which is shown in figure number A is here. Right? From this figure, let me write f of t. which is actually will become more fluent in signals and system in fourth semester, which is about which you are going to studying in operations of the signals. Anyhow, let us try to make you understand a little bit here. Therefore, this function can be written as f of t can be written as x of t into g of t, where x of t is here 5 by 2 into t, that is ramp function, and multiplied by u of t minus u of t minus 2. You can see here that x of t is a ramp function which is having a slope of 5 by 2, which is shown here, isn't it? Therefore, here u of t minus u of t minus 2 means step function minus step function delayed by 2, which is shown here. If I do multiplication of this and this, what I'm going to get? I'm going to get this function. And same is written in terms of the equation, which is here. Therefore, this is further simplified, multiplying this into this, multiplying this into this, multiplying again this into this function. Therefore, 5 by 2 into t into u of t minus 5 by 2 t into u of t minus 2. Right? Further, this can be rewritten is here. Therefore, the f of t, the finally is becomes as f of t is equal to 5 by 2 into t into u of t minus 5 by 2 t minus 2 into u of t minus 2 minus 5 of u of t minus 2. Therefore, LT of f of t is equal to f of s. That means whatever the function which is given, now we have written in terms of equation. What is that equation? If I write mathematical equation for the given function mentioned in the example, that is f of t is equal to 5 by 2 t into u of t minus 5 by 2 t minus 2 means the ramp function delayed by 2 multiplied by the step function delayed by 2, and here it is step function which is having magnitude 5 minus 5 delayed by 2. Therefore, for this, take a LT. Therefore, if I take LT for this, we'll get f of s as 5 by 2 into 1 by s square, that is ramp function, minus 5 by 2 1 by s square delayed by ramp function by 2 e to the power of minus 2s minus 5 by s e to the power of minus 2s, and 5 by 2s square, which is common in all the terms which is taken out inside the bracket, 1 minus e to the power of minus 2s minus 2 into s e to the power of minus 2s. That is the required solution for the given function which is mentioned in the terms of the diagram. Next example is here simple two example which are taken here. Find the LT of the following functions. What are those functions? Cos hyperbolic of 80 and sin hyperbolic of 80. Very simple. Now again we will have to make use of the trigonometric functions here. Cos hyperbolic 80 can be written as using Euler's identity. 1 by 2 e to the power of 80 minus e to the power of minus 80. As you all know that the LT pair, what I have mentioned in the first session, LT of e to the power of minus 80 is equal to 1 by s plus a, and LT of e to the power of 80 is equal to 1 by s plus a. Same thing you can mention here using the linear property. That is, LT of the cos hyperbolic function is equal to 1 by 2 LT of e to the power of at plus 1 by 2 e to the power of minus at. And you can substitute and simplify. We are getting LT of cos hyperbolic function, that is a of t, is equal to s by s square minus a square. Even this can be used another LT pair also. The next is cos hyperbolic of at. Same thing here. 1 by 2 e to the power of at minus e to the power of minus at. Using linearity property, substitute what is the LT of this, and simplify, and getting LT of sine hyperbolic of at is equal to s by s square minus a square. Even this can be also used as one of the LT pair. Let us take up one more example here. Find the Laplace transform of f of t, where f of t is mentioned as cos of omega t plus theta. That is space. Therefore, to find LT of this function, what I must do here, use the trigonometric functions and rewrite this as cos theta, cos of omega t minus sine of theta into sine of omega t. It is like cos of a plus b, right? Therefore, again you must use the linear property here. That is, LT of f of t is equal to f of s. What is f of t here? This is complete function. Therefore, cos of theta is taken outside and LT of cos of omega t, sine of theta is taken out. LT of sine of omega t, here cos of omega t. We have already discussed about these LTs. Therefore, substitute them directly. LT of cos of omega t is s by s square plus omega square minus sine of theta. LT of sine of omega t is omega by s square plus omega square, and simplify, will get LT of this function f of t as, that is, this value is here, s into cos of theta minus omega into sine of theta divided by s square plus omega square. Again, references which are mentioned here, go through them, go through the source material which is provided, right? And finally, again, I would like to thank learning management system team, and concluding my session here on.